Yes, thank you.
You're very welcome. Apologize for that. So remember in chapter 8, okay, like I said, kind of reiterate real quick so they can hear. Remember in 8.1, they don't give you a mean. Remember, we had a little bit of a variance. We had that point estimate, okay, which is our mean. We're going to be using the mean from 8.1. That's our point estimate. That's the guy we're going to start at. And then they gave us that formula. So we got to find that error. Remember, that's that margin of error that we've been talking about, okay? But then they say you got this level of confidence. How confident do you want to be? Do you want to be 80%, 85, 90, 95, whatever? That formula is in your book. Okay, remember at the very front of your book, I showed you where that's at. Now, I did tell you how you could find it on your own. Don't do that. Okay, one, on your final, I'll give you the a sheet of all the tables and stuff like that. Okay, so don't worry about that. But it did say, hey, once you have this point estimate, you can be confident. I don't want to say confident that the actual mean lies between this number and this number. But remember, the operative word you need to look for when doing your final is go, do I know sigma? Do they specifically say, you don't know the mean, but we do have a population standard deviation. We are giving it to you. Here it is. Then that should help you go, okay, for this question right here, I know I'm going to be reaching over into 8.1 because there it is. Okay, it's saying it. It says population standard deviation. I don't know the mean, but I do know the population standard deviation. That's important to remember. That's very important moving forward now. You're kind of starting to be able to tease out information. What do I know? What are they giving me? Okay. Can I help you out a little bit? Okay. Well, now, okay, continuing, moving on, still dealing with means. Okay, we're still going to be dealing with a mean. Remember, in statistics, you don't know for a fact. The mean, the population mean is a fixed number. It isn't going to change. But you don't know it. You will never know it. You can only be relatively certain that it's between here and here. Okay? That's how come you have that margin of error. That's what you're calculating. Okay? And it's saying, I think the mean is between here and here. Well, guess what? Sometimes you also do not know the standard deviation either. Okay? Matter of fact, most of the time, you're not going to know the standard deviation. They're not going to give you a mean, and they're not going to give you a standard. Okay? Well, thank goodness we had a gentleman, okay, who developed a way for us to kind of figure that out. Okay? To kind of substitute the standard deviation. Okay? Kind of help you out just a little bit. Now, we're still going to end up having a standard deviation, but it's going to be a standard deviation that we're going to use from just our samples. Okay? So we're going to be changing, obviously, the word now. Instead of saying sigma known after this lesson here, not this one, you got to learn a new distribution. You're going to start seeing sigma unknown. So we're going to change that sigma symbol to an S. Just like how mu became X bar, standard deviation is now going to become S because everything has moved from, you learned about populations. Now what are we doing? Everything's with samples now. Everything's going to be dealing with samples. We're doing statistics now. You're taking samples. You're running data. What can you learn from this data? Okay. So you still have the normal distribution. We all know what that is. That's that bell curve. It's defined by the mean and the standard deviation. Area under the curve is 1. You can still think of it as 1 standard deviation, 2 standard deviation. Well, I'm going to give you a new distribution. It looks remarkably close to the normal distribution, but it's called the student's t distribution. Okay, and no, it's not named after you. Okay, here's its properties, and I'll tell you how they figured it out. A student's t distribution is a probability distribution for a continuous random variable. Once again, it's continuous. Defined completely, hear this, by its degrees of freedom. Remember, a normal is defined by its mean and standard deviation. This one is defined by its degrees of freedom. And then let's look at some of the properties. A t-distribution curve is symmetric and bell-shaped, centered about zero. Same thing as the normal, isn't it? Okay, so nothing really new to understand there. The t-distribution curve is completely defined by its number of degrees of freedom. Why? Because we do not have standard deviation anymore. We don't know it. Okay? The total area under a t-distribution curve is equal to 1. That's the same as a normal curve. The x-axis is a horizontal asymptote for a t-distribution. Same thing once again as a normal. So really the only thing that's changed is instead of it being defined by its mean and standard deviation, because think about it, you're in statistics now. You truly don't have a mean that you know is concrete, and they're moving forward, they're not giving you a standard deviation, okay? Now, A1, is it possible to do that? Yes. In a factory setting, okay, I may not know the mean of something, but I could have a standard deviation because I can say my max variance is this for factories and stuff like that, okay? So yes, there is property where we know the standard deviation of the population, but not the mean. That can happen, okay? Where we get this from, just so you kind of get past the student's t-distribution, this was developed by a man named William Gossett, okay? Long time ago, 1800s. And he worked for the Guinness Brewing Company, okay? And he wanted to start taking samples and doing some stuff with the brewery, you know, because they wanted consistency. They wanted to make sure everything kind of, you know, always kept the same taste, whatever. Guinness, as they do still, had a very tight control on anything that happened at their factory, from taste, barley, you name it, even scientific discoveries they owned. Okay, and they weren't going to let him go publish this, okay, because he figured out this t-distribution. He said, hey, what if I don't know the standard deviation? And so therefore, he does this. Well, they wouldn't let him publish. So he got with another statistics guy. They published this, and this is listed as a fake name. He published a paper called Students' T-Distribution. Okay, so that's just what it's named. Had they let him, this could have easily been called Gossett's t-distribution, okay, or Gossett's distribution or something like that. But since he could not publish under his own name, he had to publish it under a pseudonym, and so therefore we get the name Students' T-distribution, okay? For us, we're just going to call it a t-distribution. Write this down. You're only going to use a t-distribution, okay, when you are not given, okay, a standard deviation, and you're using the mean as your point estimate. Okay, remember that little guy we learned in A1, okay? That's the only time you're ever going to use the t-distribution. Using them, trying to figure out the mean, that little margin of error for the mean, okay, and using, you're not given, okay, the what? What are we missing? Standard deviation, exactly. So an example question could be like, hey, give me a confidence interval of da 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 da, but then they'll say this, they'll give you a sample standard deviation. Is that the same thing? No. To do A1, you need a population standard deviation. Moving forward, if they don't give you a population standard deviation, they're going to give you a sample standard deviation, and then you can go, uh-oh, t-distribution. I can't use that z alpha over 2. I've got to use this other thing. Okay, so that's kind of like a little hint, because I don't want you to be looking at these questions later on going, how am I going to know the difference? I'm giving you little breadcrumbs to kind of know what to look for on your line. Okay? What does it look like? Well, notice they are eerily close to each other. But notice what happens. Your red line is the normal curve, the standard curve that you've been using. But then look at the degrees of freedom. Look at the one with a 3. That's the green one. Do you see how it's kind of raised up above? Okay. It kind of comes in here. I'll kind of draw a little better for you. Look right here. It kind of comes up above right there. And there's a little bit more area right there in there. It's not as close to the x-axis anymore. Okay. But then if we look at the other side, look at the student's T with a degree of freedom of 14. It's a lot closer to the normal curve. Okay? What this is saying, okay, and it still bears repeating, okay? We use the t-test when the sigma is unknown, but we still need to know that n truly should be greater than 30, or the population needs to be normally distributed still, okay? Because we're approximating a normal curve. So what this is saying is, as my samples go up, okay, I'm gonna start approximating a normal curve more and more and more, okay? It's gonna get closer. You can see the student's t distribution chart we're gonna be using at the very back of your book, okay? But you'll start noticing some similarities. If you start going like really, really high in your t distribution or degrees of freedom, they'll start closely resembling some of the tables you're gonna see at the very front of the book, okay? They're very, very close to each other because as degrees of freedom go up, we approach a normal curve. Okay? So far, so good. Don't worry about the how yet. You just kind of are you understanding the why. Okay, let's see how this works. Okay, for t distribution, your area is always going to be to the right. Okay. And to do this, we're going to use tables and calculators. Okay. Once again, alpha is your area. Okay. And notice we're going to be looking for what we call a t score. Okay. Good so far on that? Let me show an example. So find the value of t of 0.025 for a t distribution with 25 degrees of freedom. Now, for those of you using the newer calculators, you're going to have a calculator. For those of you who don't have a TI-84, you're going to have to use your book. There is no way to do this on your calculator. You're going to have to use a table. See how this works. So when you pull out your book, you notice here that you have here is your area. Down this line here is obviously your degrees of freedom. All of this right here, this is going to be your t value, okay? So notice whenever we look up, okay, the t of 0.025, I can see it right there. There it is in one tail. I come over here to the degree of freedom of 25, and notice right here, I already have it highlighted for you. So your t is going to equal 2.060. So instead of having a z score, you're going to have a what? A t score, okay? Those areas are going to be pretty much standard on how things are going to be working moving forward. Okay. Are we okay with that? Yes.
Where did you get that table from? The book or the calculator?
Book. Book. Right now in the book. Okay. And it is good to know both. Now, let me give you a little hint. Right there, that one just says find the value, right? It doesn't say left, right, in between, nothing. Okay. For those of you who are going to use your calculator, okay, and even those of you who are going to use your table, 9 times out of 10, you're always going to have a positive t-score. Okay. But your calculator is going to give you negative values almost all the time. Okay. So hear me out. You are only going to have a negative value when it says area to the left. Okay, that's the only time. You'll see one shortly. In fact, the very next question I give you is an area to the left one. Okay, I'm going to also tell you how to do it in your calculator by then. Okay, but either way, in that, you're going to have to look it up on your tables. Now, your table's never going to show you a negative. Okay, So you're gonna have to know if you're using your table, that if it says area to the left, whatever t-score you look up needs to become negative. Other than that, it's always positive. Okay? Are you good on that? Okay. Find the value of t for a t distribution with 11 degrees of freedom, such that the area under the curve to the left, hear that word, of t is 0.5. Okay? Well, looking it up on my table, let's say I do table first. I know I'm gonna have to look at what degrees of freedom am I looking for. It's gonna be 11, correct? And then my t is gonna be 0.05. And to be honest, I think it says 0.050. Okay? Where do they cross at? Should be at 1.796. Do you see that on your table? Huh? Never mind. What's the problem with that? After what I just said, what is the problem with that number right there?
It's gonna be negative, right?
It's gotta be a negative because of one specific part. Curve to the left. Okay, so that right there. It's going to make it a negative. Okay. Is everybody okay finding that on your book? Okay, you're going to get a table. All the tables are gonna be given to you for your homework. Okay, or not for your homework, for your final. Okay. But if you don't know how to read, it doesn't really matter. Okay. So here's how you would do this on your calculator. Okay, so if you have a calculator out, so here's some calc work right here. You would hit your second key, that's your shift key, remember? Then you're gonna hit your distribution key. Then, and it's always well worth checking, for those of you who have older calculators, check it anyway, you might have this button. Look for your INV T button, okay, inverse T, okay? Remember, if you do not have that button, there is no mathematical way for you to do this. You're just gonna have to use the chart in your book. Now, one other important part of this is make sure that in your calculator, okay, make sure that you highlight stats, okay? It should be giving you like data and stats. Make sure stats is highlighted, okay? And then you've got to hit in the area and the degrees of freedom. And it's going to give you, probably going to give you, if I'm correct, it's going to give you a negative value. Did it? Yeah. And that's a true negative value. You can use that negative value in this one for one reason only. And what is it? Area to the left. Every other time, it's going to be a positive value. Okay? But if it says area to the left, trust that negative value. If you're using your tables, there is no negative values. So you have to know, I've got to make it negative. When it says area to the left, okay? So don't just kind of, if you start getting a bunch of red bars all of a sudden and you're looking at your calculator knowing you did it right, just make sure, did it say area to the left in there anywhere? Okay? Like I said, anything else, don't worry about it. It's always going to be positive. Sometimes it won't even give you area to the right, area to the left. It'll just say, give me the t-score. Okay? So far, so good? Try another one then. Do this one and tell me what you would get. Use your calculator or use your table. I do not care which. You get that? Is that a correct number? What is wrong with that number?
Negative.
The negative. Do I need the negative value on this one? No, it did not say to me area to the left. It just said, give me this. Okay, so there it is right there. Round off to, let's say 3 decimal places. So notice you would have got 1.725, which probably should match what's in your table. Now, sometimes your table and your calculator are not going to be jiving eye to eye all the way up to the thousandths place sometimes. That's okay. Hawks knows which one you're using. Okay. Also, Hawks does give you a embedded table in there as well if you need one. Okay. Good on that so far? Okay. Bears remembering or telling you this real quick. So notice on this one, you get 1.725. All this is going to come to fruition in 8.3. Right now, you really need to understand how to find that t-square. Okay? Because then we're going to do exactly what we did in 8.1. We're going to start calculating the mean. Where's my mean at? I don't know. It's between here and here. Well, do you have a standard deviation? No. But I got degrees of freedom. And so we're going to start using these numbers into our error calculation instead of a z. Okay? So that's how, remember, this is more conceptual on this one. We'll move forward in 8.3 and actually get it into where the rubber meets the road. So, say anything, just remember left, negative. Anything else, go positive. Okay? Do a couple of homework problems real fast here. That you gotta kind of be careful because you're gonna have to do a little bit of math sometimes. Okay? Well, hopefully you have found this is an easy-ish math class. It is still a math class. Okay? It says select the graph which best represents this description, and it says consider the value of t such that the area under the curve between negative t and t equals 0.98. Well, if we start looking at these, remember when we say between something, that means we know that something means something. It's kind of sandwiched. And so to me, if you would agree, that sounds a lot like this one right there. And it's saying that the data, that level of confidence that I'm looking for is right here. This is 98%. Okay? You do not have a t-value that's going to say 98%. It's FYI. Okay, so hold on. Easy enough. We move over here. Let's look at this one. Assuming the degrees of freedom equals 14, select the appropriate t-value. Now, can we all agree that we were using, there was 2 tails we were looking for? Look at it carefully. Look here. Is there a tail here and a tail here? Yes. There's a reason for that, because look. If I do 1 minus 0.98, well, that's going to equal 0.02. But I have 2 tails. So I have to divide it by 2. And I get 0.010. That's the t-value I'm looking for there. So I'm looking for that t of alpha. Remember, that alpha is your area under the curve. Well, I've got 2 areas. That's why I had to divide that by 2. Okay. Make that alpha look a little bit better. Come here, I'm looking for t of 0.010. Notice I do have degrees of freedom, which is 14. I can put that in my calculator, or I can look it up on the table. But when you do this, you should get a t-value. Should it be negative or positive? Positive. Why?
It doesn't say the limit.
Doesn't say area to the left, does it? Okay, so your calculator probably gave you a negative value. Okay. But it's going to be 2.625. You get that? All right. They don't take mine out first. Give me a second. Going too fast, and I too am not wearing my glasses, let's see. See, she forgot hers, mine are right here. Second. Area of what? 0.010. Our degrees of freedom is what? 14? Yes. 2.62, well, 2.624. Okay, if you use your calculator. Okay. Good on that one? Okay, but it did give me a negative. I was double checking on mine. I want to make sure it gave you a negative. Reason it's giving a negative, guys, is this. Remember, let me just kind of back up. Are these symmetrical? Yeah, a T distribution is still symmetrical. I'm just gonna look at this one here. Notice there's a T score. Let's look at this one here. There's a T score right there, isn't there? Wouldn't it be negative? There's also a T score here also. Wouldn't it be positive? Your calculator is defaulting to the negative side. There's actually two T scores. There's a negative and a positive. Okay, so that's what I'm saying. Okay, that's why it's defaulting to negative on your calculator. Okay, but we don't need the negative. We need the positive number unless it's doing area to the left. Because area to the left is just going to be negative. Okay, yes, ma'am.
Did it give us a different answer on the calculator than on the paper?
Yes.
Why?
Your calculator is going to be going at a more accurate. Okay, because remember, your calculator is going to like infinite decimals. It's saying, I'm going to calculate all of this. Your tables are rounded.
So what is Hawks gonna do?
Either one. Hawks knows to do either one. It's going to know if you rounded correctly or if you're using your table. Because it allows for that little bit of variance. Because Hawks is running both. Hawks has a built-in table and it's also got a built-in calculator. Okay, so it's going to be able to go both. Okay, and they're gonna be relative. If you're getting way, way off, check your numbers. Okay, you're gonna be within thousands. You're not gonna be like off, like get 2 point, like on this right here. You wouldn't have gotten 2.6 or 2.7. Wouldn't have happened. Okay, that's a totally different area right there, 2.7. So kind of help you out a little bit. See one more. Then we're gonna get to 8.3. By the way, as I do this, just FYI, all lessons have been uploaded. Did you, anybody see that? All lectures are uploaded, all notes have been uploaded, so everything's there. Alrighty, consider the value of T such the area to the left of negative T plus the area to the right of T equals 0.1. Well, let's do it this way. This is A, B, C, and D. Which one do we believe it is? Can we rule out A and B?
Yeah.
Yeah. Why do you think that?
But they have one.
Was that?
They only have one zone.
I can't hear you.
They only have one zone.
Right, they only got one tail. And this one has the word left and the word right. Okay, how about C? You don't like that one? Okay, and then D. What would be the operative word for D that you would look for? Between, exactly. You look for the word between. This one is saying, I need something here and I need something here. You also might look for the word differs what? Differs more than. Remember that word when we use that differs more than or differs what? For the other one, for D, you'd use differs less than. Okay, so kind of look for that too, kind of learning about your words. So yes, we're looking for C. Are we looking for a one tail or a two tail? Two, because there's two tails there. There's two alphas we're looking for. Okay, well, also, am I gonna, just knowing what I know now, am I gonna get a positive or a negative value? Could be negative? Kind of a tricky question, isn't it? What did I tell you to look for? When it says what? What else does it say? The only time I said you're gonna get a negative value is when it says what? And that's it. Okay, it's only gonna say area to the left. It's not gonna give you anything else. It's not gonna say area to the left and it's just gonna say left. Okay, so this is gonna be a positive one again. Because it's gonna default to that first one it hits. Well, there's still another tail out there. Kind of help you out a little bit? Alright, do the math on it. Here it is, they're giving you some degrees of freedom. Can I use that 0.1? No, what do I have to do to that 0.1?
Divide by 2.
Divide by 2, and the operative way I know to do that is because I'm dealing with two tails, okay? So yes, I'm gonna come in here and do that 0.1 divided by 2, and that's gonna give me 0.050. My degrees of freedom is equal to 8. So I should get a T 0.050 is equal to. We're still working on it. Unless I see more eyes looking at me, I'll write down the answer. About 1.860. Remember, Hawks will count it wrong. So, and I say this because remember your finals on Hawks. Okay, Hawks will count it wrong. Now I'm going to put eyes on everything, but Hawks will count it wrong if you do not put that 0 there. Okay, because when it says round to 3 decimal places, it wants that third place. Okay, even if that third place is a 0, it still wants it. So, trying to save you some red bars. Because those are annoying, especially on a certified.
To the left. Mister, on the last one, you subtracted 1 minus the.
Well, I did 1 minus on that one because look at it. They give me 98%. Because look at where the area is at for this one. I need the area of the tails, right? It's always area of tails. Okay, matter of fact, even whenever you look in your book, what does it say? Like the very top part, it says how much? Area of these tails. Does it say 1 tail or is it a 2 tail or something like that? So we're not looking for the area inside. I'm looking for the tails. Okay, so that's how come that one right there was a 1 minus. If I did 1 minus this other one, you're gonna get 99%. Divide that by 2, you're not gonna find that on your little chart. Every little thing you're gonna be able to find either. Every number they're gonna give you is gonna be on that chart with you. Because they're kind of standardized, okay? Now let me give you a little hint if you're gonna be using your chart, okay? Not for your final because I'm a little bit nicer than that. But hear me out. Degrees of freedom. Whenever it starts giving you degrees of freedom, if you start looking at that little chart in your book, it's gonna start skipping numbers on you eventually, okay? I don't know when, I forget, I haven't looked at the chart this semester because I mainly use my calculator, okay? But let's just pretend it gets to like 200. Well, it's not gonna go to 201, 202, it starts jumping, it starts going to like 210, and then like 500, it may jump to 550, then 600, and then it goes by hundreds or whatever. Here's what you do. Always go to the next one below. Okay, now let me tell you why. As we jump into 8.3, this is kind of a good little transition sentence. Help you out in English class. Little transition sentence before you get to the next paragraph. Degrees of freedom are your samples. That's what you're going to see moving forward. They're going to say, here's how many samples I'm giving you. Okay, or I took a sample of. Well, they're giving, that's the degrees of freedom. Okay, so that's what I'm saying. As your degrees of freedom go up, it approaches more a normal curve. Well, now you know degrees of freedom means your samples. As the samples go up, the more this thing's going to approach a normal curve. Okay. Now, having said that, just kind of think about that as we move forward. Now, when you do that and you start looking at degrees of freedom, like say it says, hey, I'm giving you 762 samples. You go on your deal and go, well, it's only giving me 750 on degrees of freedom, and it gives me 800. Would you round up or round down? Now think about what I just said. What is degrees of freedom? It is what?
Sample.
Samples. Would you round up or round down? Why down?
You're gonna get a total big number.
I think you're gonna get a bigger number, but also think about it. If it's samples, I just added samples to my study that aren't there. If I'm at 762 and I boost that bad boy up to 800, I literally just added in I added in 38 people that I didn't study. So it's always better to round down. Because I may be nixing some people, that still sucks. But it's better to nix people than add ghost people that aren't there. Okay, because that's when you start seeing data become skewed a little bit, or people going, that sounds a little weird. Okay, because remember, the central limit theorem works, but it's still gotta be accurate with your math. Okay, and how you do things. Kind of help you out a little bit now. There is one more little thing about degrees of freedom, but we'll get to in A3, which we will start right now. Any questions over this as I kind of get transitioned over? Notice now. Estimating population means, but now what do we not know now? We don't know sigma anymore. Okay? That's why we have that student's t-distribution. This is the whole reason for it. And it's only used when you're doing what? You're looking for the point estimate to be a mean. Okay? In this chapter, we're going to learn about proportions. We're also going to learn about variances. But for right now, the soul of our life is going, okay, I've got that point estimate of a mean. But then they're going to tell you, and they may not say sigma's unknown. But I can tell you this, you're not going to have a question on your final that says sigma unknown. But if you're not, you're going to know, you should know it because it's not going to give you a population standard deviation. It's only going to give you a sample standard deviation. Well, if I'm only giving you the sample, what am I not telling you? The population. Those are the connections you've got to start making, okay? So you got to be slow and intentional on how you read these questions, okay? Because they're going to give you enough information, I promise you. It's not going to be hidden from us. So what are we looking at here? We're going to have to go through some definitions again real quickly. They're going to change some things on you. You still have to make sure all these conditions are met, okay? Because I am benevolent. These conditions will be met on your final. They may not be met, okay, on your homework. Okay, so kind of be careful, okay? You need to make sure that the samples, that all samples of a given size have equal probability. Sample standard, population standard deviation, hear that word. Population standard deviation is what? Unknown. You don't know it, okay? And that either the sample size is at least 30 or the population distribution is approximately normal. It will tell you one or the other. If they're only giving you 8 samples, I guarantee you inside that question somewhere, it will say the words, assume the population is normally distributed. Because they're going to make sure that they're catching it on one side. If they don't say that, and then they give you a low sample size, they're probably going to give you a button in your homework that says, can't do this. Okay, I can't do this because the conditions are not being met to do this, okay? Don't expect that too much. That's sort of like I tell my intermediate advocates, you know, don't put not factorable so much. Not everything is not factorable like you think it is. How many of you are not factor teams? You know what that is? That person who just put not factorable on everything, just hoping it would just like, maybe it'll work out. It doesn't. Okay, look here. Gonna give you, we're changing a definition. Remember when you found E? There is your new way to find E when sigma is unknown. Okay? You don't remember. Let's remember if sigma was known, it's always good to review. You had this, Z of alpha over 2 standard deviation. Remember that one? That formula for that one? Okay. You also had a calculator button. Okay. By the way, if someone will remind me, I'll bring your note cards next class. And if you're hearing me online, for the final, they are allowed a 3x5 note card to take notes on. They can put whatever they want on it. I wouldn't waste space because I do give you the formulas and I do give you the tables and everything else, so I would just put hints, help, or whatever. But I will, in this class, for you in-person people, I'll give you note cards myself. They're nice little fluorescent note cards that I can see plain as day. Okay? So if someone will remind me, because I am forgetful, this has been a busy week. Okay, I'll bring them to y'all so that we don't have to go by them. Okay, so notice when you're looking for error and sigma is known, this is the guy you're using. But notice if sigma is unknown, we've changed things up. Specifically, what does that symbol mean right there, that little S? Sample what? Standard deviation. That's the sample standard deviation. Okay. And then, of course, it's got, instead of a Z score, they're giving us a T score. So you have to go look up the T score, so on and so forth. That little n is still your sample size. And then there we go. Will you get this on a formula sheet? Yes, but a lot of good, it helps you if you don't study. Okay. Like studying Greek, because there's Greek letters in there. So let's look at this right here. Dental researchers want to estimate the mean leakage measured in nanometers of a new filling material for cavities using a simple random sample of 10 trials. Listen to these words. Assuming the population distribution is approximately normal, kind of needed that, right? Why do they need to say that?
That's what the criteria is.
Well, the criteria, because notice the number of samples they said, well, that's well below 30. So they need to put this, hey, this is approximately normal, okay? Assuming the population distribution is approximately normal and the population standard deviation is unknown, that should be kind of like your little bat sense, your little, was it, your little spidey sense should be going off right now. Find the margin of error for a 95% confidence interval for the population mean, given that the sample standard deviation is 15.5 nanometers. Look at that word right there. They're giving us the sample standard deviation. Okay, so it's always good to kind of parse everything out. What are we looking for? Well, let's notice that they're saying, hey, we've got this normal curve here. Drawing is still very helpful, I promise you that. And we have 95% here. But I'm actually looking for this, aren't I? That sound like a 1-tail or a 2-tail test? Okay, I'm helping you, I promise you. By you understanding now when things are 1-tailed and 2-tailed, that's why the drawing works, okay? So realize what I'm actually looking for is this. I need to find a T-score, don't I? Because I've got to start kind of like picking all of this out, okay? So let's pick out what we know to find first, okay? We have a formula here of E is equal to T alpha over 2. And then instead of standard deviation of sigma, we're going to be using what? What's our symbol? S. And then everything stays the same that way. Pretty much only one little variable's changed. I say variable, it's not really, it is a variable, but I don't really like using that word. Okay, T alpha over 2. Well, what is it? Well, wouldn't I do this? Wouldn't I do 1 minus 0.95? Correct? And then I get what? 0.05. So that's a good number right there, right? Huh? No.
By 2.
I divide by 2 because I'm looking at a 2-tail test. So I divide this bad boy by 2 and I get 0.025. So I'm almost there for my T-score, right? But I need one more thing. What else?
Degrees of freedom.
Degrees of freedom. Do they give it to me? Do they specifically say the word degrees of freedom? No. Here's your degrees of freedom. Your DF is equal to N minus one. You need that level of correction. Remember back in the day when we had that minus one? Remember we had that big N? And then we had that N minus one? That's that level of correction, okay? So my big N is gonna be what? What are my trials?
10.
10, so 10 minus one.
No.
There's your degrees of freedom. It's going to be 9. That isn't, do I need to see your work of you doing minus one every time? I mean, if you can't do minus one, we have a way bigger problem. Then, you know, you could be able to pass this class, okay? So I don't need to see it, I'm just kind of showing you for the sake of it. Do I have an S value, which is my, what's my S again? My what?
50.5.
So what is it? What is my S? Sample standard deviation, and he's right, 15.5. And then, of course, I do have an N value. Please don't put the minus one. When you do have your N value, you got to keep the original N as well, okay? You've got this 10 here. And now we have something we can put into a formula. Remember, we're just looking for the error right now, okay? So you come in here, one, you need that T value. You can either use your calculator or use your table. I do believe I have I think on here, and it's gonna kind of blow over just a little bit because I've drawn a little bit. But notice here, I do give you a T value right here of 2.262. So I can come in here and put 2.262. I know I'm not using a negative value because did my picture show anything to the left? And that's it? No, it didn't. Okay, and then I come in here and keep putting stuff down. I've got this 15.5 here. And I'm divide that by the square root of 10. And it's good to go pretty far out. Now, I don't know exactly what Hawks is gonna tell you, but on some of these, I'll tend to sometimes even go to 6 decimal places out, okay? So my error is going to be 11.087262. That's your error. What would I be doing with that error eventually? What did we do in 8.1 with it? Plus or minus. That's all you're doing now. You're still trying to find that plus or minus. I've got a point estimate, right? They're gonna give me a mean. And then I've got to take that error and do what with it? Plus or minus, and then I'm gonna be able to say, hey, my mean, I think, is between here and here. You're still doing the exact same thing you did in 8.1. It's just now you don't know your standard, you don't know that population standard deviation anymore. Okay? So like I said, very good. That's what you're doing right there. You're taking that. Notice how they wrote it. You can write it either way. See here. Close it off. That is not a coordinate point. Okay? That's like, remember intermediate and also college, remember interval notation? Same thing, it's like interval notation, okay? We just cannot equal it, okay? To equal something means you know it equals it. Do we know specifically for a fact that that equals anything? No. We are a level of confidence secure that this is what this thing is saying. Could we be wrong? Yes, that's the nature of statistics. That's the nature of research. You could be wrong. But our educated guess and the math is telling us this. And then maybe someone else is going to come along and do some more math and maybe verify us or blow us out of the water and realize that we were completely wrong. By the way, did you read the news yesterday about them bringing back an extinct animal? Did you see that? That was insane. They brought back a dire wolf. That thing's been extinct for 10,000 years. And they injected his DNA. I said, there's a movie about why you shouldn't be doing this. You know? And yet people are doing like, man. I thought it was bunk. I was like, whatever. I had to like Google it a few different ways. I was like, okay. And if you actually go read the news story, it's not as cool. They took some pieces. It's not like a complete extinct animal. They just took some like snippets of a dog or a wolf, a gray wolf. And said, let's just shove in some of this other stuff and kind of make it look like this thing. So it's not really like, they didn't like bring back a velociraptor in it. They didn't take a rooster and turn it into a velociraptor, okay? So So it makes for good news, I guess, but it caught me for a little bit, but I say that, hey, statistical thinking told me to do what? I didn't just read and be like, wow, that's kind of neat. What did I do?
Investigator.
I'm gonna investigate that a little bit because outstanding claims should require what? Outstanding evidence. You know, so yeah, I would, because it is on cover of Time. They show this picture of this wolf. These things are puppies. How do they have a big wolf already? Okay, but it was cute. I thought it was cute little. But it's gonna get big. Like I guess they say this thing when it's full grown. There's two of them. They're unknown location because you know some hunters out there are like I want to bag me a dire wolf. You know, but I don't know. Kind of it is interesting. You know where stuff goes. Be careful. Look at this one right here. Let's do an example here. A marketing company wants to know the mean price of new vehicles sold in an up and coming area of town. Marketing strategists collected data over the past 2 years from all the dealerships in the new area of town. From previous studies about new car sales, they believe that the population distribution looks somewhat like the following graph. Okay, kind of nice so far. Could we say it's kind of normally distributed, maybe a little bit? Sort of, but what's the problem with it? What would you actually call that graph? It's always good to be reviewing, always. Skewed where?
Right.
To the right, because you always get skewed toward the trough, okay? I got pulled to the peak just then. So it's always good to read. So let's look at this a little careful. The simple random sample of 756 cars, is that enough samples? Yeah, because we just need 30. They gave us a lot. A simple random sample of 756 cars has a mean of 27,400 with a standard deviation of 1,300. So they just gave me the population standard deviation? No, what is that? That's a sample. Notice they didn't tell you anything. Did they ever say the word, hey, the population standard deviation is unknown? No. You're just assumed to know it by the way they wrote the question. And that's exactly how your final is going to work. It's just going to assume you know because the way they word the problem. Okay, so be careful about that. Construct a 95% confidence interval for the mean price of new cars sold in this area. Okay, we'll start parsing our information out here and realize we do have an end, don't we? Of 756. You agree with that? What would be my degrees of freedom? Thank you. How'd you do that math so hard? What'd you do? -1. There you go. So that's all you gotta do. -1. So my degrees of freedom is 755. Not sounding belittling, though it is hard math if you don't know, right? What would be my standard deviation? Okay, exactly, 1,300. That's sample standard deviation. Okay, they give it to you. Do they give me a mean?
Yes.
What is it?
7,400.
Very good, 27,400. All righty. Do they give me a t-value? No, I'm gonna have to find that myself, aren't I? So if I'm looking for t of alpha, well, I don't know what that is yet, but they do give me a confidence interval. Okay, so let's come over here and I've got 1 minus 0.95. That's gonna equal 0.05. I'm gonna divide that by 2. And I get 0.025. Having that and my degrees of freedom, I can put that in my calculator or I can look it up on a table. Okay, but I know that my number is going to be 1.963. I want you to make sure that you're getting that number because you don't want to be know how to do your calculator. Good so far? Alrighty, and then we got a formula here. I've got E is equal to P alpha over 2. And then the standard deviation divided by the square root of the number of samples. Come back in here. I'm going to use that 1.963. My samples is gonna be 1,300. Divided by the square root of 756. I get roughly 92.81. Notice they don't give me what to round to on this one. Okay. What am I gonna do with that though? Because this wasn't find the error, this is find the what? Confidence interval. So don't I need to take this mean, right? And do what with that error?
Add and subtract it.
Yeah.
with, 27,400.
Exactly. I'm gonna take that mean and add and subtract it to that E. And so I'll take that 27,400 and plus or minus this 92.81. And here's my answer. Now, my answer, I rounded up to the nearest dollar. And there's a reason for that. Look at how they gave me all my numbers. Do you see cents there? No, so round to the nearest, okay? And I would write it like this: 27,308 and 27,493. Or you could always write it this way: 27,308 mean 27,493. That's all well and good, but what does that mean?
That the mean can range between those two numbers.
Yeah, the mean of what?
Population. The price of
Population.
cars.
The price of cars. That would be the price of cars, I think, within that area with how much confidence? 95%. Remember how we decide confidence, okay? If I took 10 samples, okay, I would think 95% of my samples would contain the mean. It's not that you're 95% thinking that you are correct. Don't think of it that way. Out of 10 samples, 95% will contain the true mean. Okay, so you took another sample and another sample and another sample, you say, I believe this. Okay, you don't have to take 10, but you could kind of say it that way. Okay. There you go. That's exactly conceptually what you're looking at here. Let me let you do one on your own real fast and let's see how you do it. Give me a couple of minutes on this one and then I'll play catch up.
Isn't the sample less than 30? So.
Good eyes. Don't feel bad. He asked, he goes, isn't the sample less than 30? Correct. Okay, so keep working, but had that not said the words normally distributed, you could not continue on with this question. Okay, you need one or the other. Okay. Everybody get that? Any trouble with it?
How come it being normally distributed makes the sample size okay?
Because you need one or the other, because being distributed normally means it's symmetrical, and so therefore you can do the T distribution.
So as long as one of them is there, it's good.
Yes. Remember, central limit theorem says what? The more samples I take, the more things are gonna become normally distributed. So if I take a sufficiently large enough sample, which is proven by the central limit theorem, and the central limit theorem says you need a minimum of 30 for these samples that I'm taking out of some population that's probably not normally distributed, it will approximate a normal curve. Therefore, I can use all those deals, tool reviews. Or I can go less, but then things need to be normally distributed.
Down to 35.
Because it told me to on the question.
Oh,
Good question. No, it's a good question. So. Does that answer your question? Does that answer your question back there? Anybody else have any other questions? So what are we looking for? How do you know? Let's be honest, you just want to pass this class. So how do you know? What are you looking for? When you get a question like this on your final, how do you know you're going to be using the T distribution and not a Z? What's some operative things you need to be looking for? Are you dealing with a mean? Ask yourself that. Is your point estimate going to be a mean? This plus or minus guy, that X bar, or is that what we're dealing with, an X bar? Yeah. It explicitly states that, right? It says up there, there's a mean. I have a mean, there it is. Okay? And then it says what? What's something else you're looking for? You need to look at the samples, you need distribution, but you need to look at that standard deviation. And then what kind of standard deviation are they giving you? Is it a population standard deviation? No, I'm saying, what are you looking for? Like, am I gonna be using 8.1 Z-scores or am I gonna be using 8.3 T? 8.1, hey, population. I'm going Z-score. And I'm gonna be using that population standard deviation. Oh, we're using samples. Looks like I'm going 8.3. Okay. Everybody good? Next class, we're gonna start doing the same thing. Okay, estimating proportions. Hear me out. The only time you're going to use a T-score is when we're doing means. Okay? Everything else after this again is we're gonna be using that critical Z. Remember that little critical Z table that we were using? That's in your book?
Yeah.
I suggest bring your book so you know how to find that instead of me just giving you numbers. If I keep giving you numbers, you're not gonna know where to find these. Okay? So kind of keep that in mind. Okay, there's the front of your book. Okay, and plus you're gonna need your book here pretty soon because there is something you cannot do in your calculator. And it's gonna be a chart, and it's kind of weird to read. Okay, we're getting very close to it. Okay, bye. I'll see you guys next class. Awesome. There is some more homework help, by the way, on there if you want to look over the rest of the notes.